So we are starting chapter 7, it looks like, today, and we're going to review our exponent rules. So it's probably been a little while since we've actually gone over all these rules, although we have been using them for quite some time. So this is the introduction to the product rule with positive exponents, and it's a whole number base. So that means, we have a whole number down here on the base. So exponents are used to write repeated multiplication. We want to remember that. If I see, 4 squared like I do here, it doesn't mean 4 times 2. It means 4 times itself 2 times. So 4 times 4. Or 4 to the 5th means 4 times itself 5 times. So 4 times 4 times 4 times 4 times 4. Okay, so that exponent tells me how many times I'm multiplying the base by itself. So let's look at 2 methods below to learn the multiplication properties of exponents. So now we're going to look at the expanded form, what I was just talking about out loud there. So we have 4 squared and we have 4 to the 5th power. So if we're looking at the expand method, so this is just one method, we're going to look at 2 of them. I can expand it and I can show, well, 4 squared means that I have 4 times 4, and 4 to the 5th means I have 4 times 4 times 4 times 4 times 4. So I have all these 4s, and if you notice, they're all being multiplied, right? There's a multiplication dot here, there's a multiplication dot between all of them. So I can just simply count the 4s. I have 7 of them, so it's 4 to the 7th power. And that's rewriting it using a single exponent. They're not actually asking me to evaluate it and say what is 4 to the 7th power. They just want me to rewrite it using one exponent. So method number 2 is to add the exponents. This is actually the product rule of exponents. So I can look at, as long as I have the same base, I can look at the 2 exponents, 2 and 5, and I can add them together, and that'll be my new exponent, 4 to the 7th power. So 2 methods. The second method is definitely one I'm going to push you toward because it's an easier method to apply on a regular basis than having to always expand the problem. But I'll show you, quite a few more expansions so you can see it happening. All right, so if we look at the bottom one, we have y to the 5th power, y, and y to the 5th power again. So we have 3 different situations here. So if I expand it for the first one, you can see here are my first 5, here's my 1 in the middle, and here's my second 5. So I have all of these y's. Now if I count them, this time I have 11 of them. So I'd have y to the 11th power. Oh, that should say 11, not 4s. Ha ha ha. Because I just forgot to change that from the first one. So if we look at the second method, we can add, as again, they all are y's. They're all the same base. I'm going to add the exponents. We just need to make sure that we're paying attention that if I don't see an exponent, it means it's 1. So we don't want to just skip over the 1 in the middle and go, oh, but it's not even there. It's a 1, so it's 5 plus 1 plus 5, which is 11. So I still end up with y to the 11th power. All right, let's look at a couple more of these. So we also have product rules with positive exponents that we can multiply with our coefficients. So when the variables have coefficients, we must multiply these numbers, that's what a coefficient is, as well as combine the exponents of the variables. Okay, so we're going to simplify our answer as much as possible. So we have negative 4u squared times 7u. So we're going to multiply the coefficients, negative 4 and 7, and then we're going to deal with the variables and their exponents. So negative 4 times 7 is negative 28. So now let's deal with our exponents. So I can add those 2 exponents together because it's base u. So 2 plus 1 is 3. So I get negative 28, because that's already been figured out, u to the 3rd power. So that's simplified as much as possible. All right, so the next one we have, again, simplify as much as possible. Now I have 3, 5, and 2 for my coefficients. And I have v showing up twice, and I have y showing up twice. So I'm regrouping them. I don't know if you noticed that in the first one. I regrouped coefficients first and then the variables. In this one, I'm going to regroup coefficients. I'm regrouping the v's and then regrouping the y's so that it's very easy for me to see which ones I'm going to be combining. So 3 times 5 times 2, well, that gets me 30. So I could go 15 times 2 is 30, or 10 times 3 gets me 30, however you want to combine those. Or 6 times 5 gets me 30. You can multiply in any order you would like. So now we're going to deal with the variables. So I have the same base, v and v. I can't combine a v and a y. I have to have the same base. So v and v, I have 2 plus 1 again, so that gets me 3. And then for y, I have 9 and 3. So 9 plus 3 gets me 12. So now I can rewrite this as 30 v cubed, because that's what I got for my v's, and y to the 12th power, because that's how many y's I have here. And again, you could expand this all the way out and show all of your pieces here. I was hoping that I had done it for you, but you're definitely going to have a lot of pieces to show if you expand it all the way out. All right, so this is the product rules for exponents. I hope that helped, and I will see you in the next video.